we begin with the complementary part, whereby we are going to let our y to be equal to exponential mx. Then we get our y prime by differentiating y once, which will give us m exponential mx. And we differentiate our y twice to give us m squared exponential mx. Then we substitute the value here. So our y complementary, our equation which is complementary part of it is, will be given by that. Yeah, that is the equation. The y should be there, which is equal to 0. So when we substitute, we will have m squared exponential mx plus exponential mx is equal to 0. We factor exponential mx so that we get m squared plus 1, which is equal to 0. And we note that exponential mx can never be equal to 0, meaning that our m squared plus 1 is the one which is equal to 0. So m squared is equal to -1, taking +1 the other side. Then we take square root in both sides so that m will give us a plus or minus I. Then from there we write our complementary solution, which will be of the form yc is equal to c1 sine of x plus c2 cos of x, where c1 and the c2 are the essential arbitrary constant. Then in symbolic form, our y particular will be equal to d double prime plus 1 into bracket y. This is given by x that, which means that our y particular will be x cubic divided by d squared plus 1. D squared plus 1. Then this can be written as follows. So we can write this as 1 plus d squared power -1 x cubic. And by now we found out that yp is equal to 1 minus d plus d squared minus d cubic x cubic. We submit x cubic to this, whereby we will get x cubic minus 2x squared plus 4x minus 4. Here we differentiate x once to get this is 3, sorry, to get 3 x cubic to multiply by 2. Here we are going to get 6, and this other part here is 6. So when we differentiate x once, it is 3x squared. We differentiate this again to get 6x. We differentiate this third time to get 6. So our OD was the second derivative of y with respect to x plus y, which was equal to x cubic. So our solution of this one will be y is equal to c1, y complementary plus y particular, which is equal to c1 sine of x plus c2 cos of x plus x cubic minus 3x squared plus 6x minus 6. So that is our solution of our given ODE. This is the complementary part, and then this is the particular part, whereby we have multiplying by this one and submitting x cubic to this part here to obtain this result. Thanks so much for taking your time to study with me. For more such learning, kindly tune on to my YouTube channel so that we may continue learning together. Bye bye. See you in the next presentation.